another one of my Leetcode videos. In this one we'll do Leetcode 543, diameter of a binary tree. This is part of my playlist for Leetcode Google interviews, so if you want to see other videos on Google interview questions tagged on Leetcode, then please check out that playlist on my profile. So let's get into it. So the diameter of the binary tree here is defined as the length of the longest path between any two nodes in the tree, and they note that this may or may not pass through the root. So the length of the path is represented by the number of edges between them. So in this case you can see that the longest path is this path over here from 4 to 1 3. It has 3 edges, so the answer is 3. And if we look at other paths like 4 2 3, it's not necessarily a longest path because the size is only 2. And you might be wondering, okay, what is a case where this is not passing through the root? So let's draw an example. So if you have a tree like this, the longest path is like 1 2 3 4 5 6 7 8, and this is through this node. But if I pass through the root, you can only pick one of these. You can't have both. So it's gonna be 1 2 3 4 5 and 6. So if we include the root, the longest path is only going to be 6, but actually the diameter, which is the longest path in the entire tree, is found over here, which does not include the root, and it's 8. So in this case the answer will be 8. So how do we go about solving this problem? So if we just calculate the sum of the depths of the left and the right at each node, we'll find the longest path that passes through that node, right? So in this case the left subtree has a depth of like 1 2 3 plus 1 because it's attached to the node, so this is going to be 4. And the right subtree also has a depth of the same thing, 4. So it's like going to be 3 plus 1 4, and if you add those up together, 4 and 4, you'll get 8, right? So at each node we can compute that like sum of the left depth and the right depth, and that will be the depth at that node. But then our final answer won't be that value at the root, because as you saw earlier, if we apply the same logic at the root, it's going to be over here like 5, because it's only 5. The depth here is 5 plus 1, or 4 plus 1 5, and over here it's like 0 plus 1, which is 1, and that's why we have 6, right? So we can compute the sum of the left and the right depths, but our final answer won't be the depth at the root, but it will be the maximum of that sum of left and right at any node, right? So in this case, since it's 8, and in this case since it's 6, we keep track of, as we are computing these like sum of left and right on each node, we keep track of it and keep the maximum, and whatever is the maximum that we've seen, that will be our final answer. So in this case it will be 8. So if you had like a really super long subtree over here, that makes this one the maximum, we would note, let's say for some reason this was like 100, right, for example. So if we kind of like keep track of that 100 and max it with every other node that we calculate for, then eventually the 100 will be the max and we'll return that correct answer. So basically the way we're going to implement this is just compute the depth, left depth plus right depth at each node, and then take the max of all of those and then return that. So let's get into the coding. So the first thing I'm going to do is create a function that will allow us to traverse the depth, and it will actually return the depth of the node because we want to recursively keep track of the depth, but it'll allow us to traverse the depth of the node and it'll keep track of the max, right? So we'll take in a node to traverse, and since integers are primitive types in Java, we'll create like a max container. so we can keep track of the max and like mutate this same object if we find a new max. I'm going to go ahead and write the max container class. Okay, so I've written the max container class. All it is, it just holds a max. It gives us a constructor to like set the initial value. And then every time we encounter a new candidate, we call this track method. So it'll just, max the existing max in the new candidate. At the end, we'll return this max. So let's write the top level function so we can see how the bigger picture fits. So we'll create a max container MC with an initial value of 0. And then we'll call traverse depth with the root and the max container. And at the end, we'll return mc.max. So in the traverse depth function, if we'll look at the left depth and the right depth, right? So if the root.left is not null, our left depth will be equal to traverse depth of root.left plus 1. And if root.right is not null, the right depth will be the same thing, traverse depth of root.right plus 1. And our initial values will just be 0 and 0. Is not null, we'll traverse, find the depth of the left one and add 1. And if the right is not null, we'll find the depth of the right one and add 1. Right? So if you reach a leaf node, both of these will be null, so it'll just be like 0 and 0. And then at the end, we'll just return the max of our left depth and right depth. So since we're already adding 1, that will be it's already accounting for the edge to this new node. But then now we just need to keep track of the maximum path through this node. So what we'll do is mc.track, and our maximum path would simply be the left depth plus the right depth, right? So in this case, like if it's a leaf node, both of them will be 0. But if we reach this node, it's going to be 1 plus 1, because the left depth is, for this node, it's 0 plus 1 because we did a plus 1 here, and the right depth is 0 plus 1 because we did a plus 1 here. And if this happens to be null, then it'll just be 0 altogether, and we won't have this artificial plus 1, which is desirable. So this will end up counting the path through the root. And for here, this will track a path of 2, but then it will just return 1 because the depth of this node is 1, right? And so when we get here, the left depth will be 1 plus 1, because we're doing a plus 1 here, just going to be 2. And then the right depth will be just a 0 plus 1, so it's going to be 1. And so when we track left plus right, the path is going to be 3, but what we're going to return is 2. So eventually the maximum path will be tracked in this max container, and we'll return mc.max. So let's see how that works. Oh, we need to pass in our max. Oh, this needs to be max. Cool, accepted. I hope you enjoyed the video. I'll see you in the next one. Cheers.